Hey folks, how you doing? We're taking a look at the median of grouped data, which is on page 11, and it'll go through to about page 14, I think it is. Yeah, there we go. So you'll recall that when we took a look at the median of ungrouped data, let's just take a look up here. It's the value that is the middle value in a data set. So for instance here we've got the number 9, which is right in the middle of those numbers right there. And of course if there's an even number of values, then it'll be halfway between the two middle numbers. We used a formula n plus 1 divided by 2 to find the rank of the value, and then found out what that actual value is in the data set. Remember that the data needs to be put in order. Now, when we're talking about group data, there's two differences that we're dealing with. One is that we're typically not dealing with a small number of values. So in the above example, if you have something like 5 numbers or 7 numbers or something, then of course you use the formula n plus 1 divided by 2 to get that it's the third value out of 5, or it's the fourth value out of 7, or it's the 3.5 value out of 6. And that's really important when you can see all of the numbers and it's a small number of values. But typically when we're dealing with group data, it's because we're dealing with a large n, a large number of values. That's why we put them into a table. So think, for instance, of the 100,000 people in Red Deer, and back in I-6 where we looked at their ages, and they were put into classes. So we had 0 to 4 years old, and we had a number of females in the thousands, number of males in the thousands, and then the total number. And similarly for the next classes. So that's the most important thing, I think, to keep in mind with this, is that we're dealing typically with large number of values. We'll only be taking a look at the 50 values, like the ages of 50 people or the marks of 50 students, or even smaller groups than that. But when you're talking about 100,000 people, really when you're looking at the age difference between the 50,000th person and the 50,000th and a half person, there probably isn't any difference at all. The second main reason why we don't do the n plus 1 divided by 2 is that it's, as soon as you put the data into classes, you lose some of the precision. You don't know the exact numbers. All you know is that within this particular class, such as, again, taking a look at the ages of kids, we've got 0 to 4-year-olds, and we've got about 2,000 females in there. So we don't know the exact ages of those 2,000 kids. We just know that they're in the class 0 to 4-year-olds. So you lose some of the precision. We don't know the exact values themselves, just how many are in the class. Because of that, we don't use n plus 1 divided by 2 to find the value of the median. We use just simply n divided by 2. Or another way of saying n divided by 2 would be 0.5 times n, where n is the number in the population, or of course it could be a little n if we're talking a sample. But the 0.5 here then is the 50th percentile. And the 50th percentile is another name for the median. It means that 50% of the values are less than it. Think back to maybe when you were a kid. Of course, you wouldn't have remembered this, but your parents would have, and they might have told you this, or perhaps your parents yourself, and so you've got a kid which is maybe in the 95th percentile for height. And that means that 95% of the kids are less tall, they're shorter than you are or your kid. So that's what we mean by the percentile. And so the median then is the 50th percentile. Half of the values are below it and half are above it. All right, so let's take a look at a really simple example here when we're taking a look at the median of the TV ratings of the Business and Bin 111 students. And we've already seen this example before, but what this table here shows you here then is that if we were to write out all of these numbers in a long line from left to right, then this shows us that we have 2 1s. So we'd have 1 1 and then followed by 2 2s, and then we would have 6 3s, 1 2 3 4 5 6, and that would go all the way up here. And then we'd have a whole bunch of 6s here. There's actually 19 of them. And then we would continue on until we end with the 2 9s. There's no 10s here. And what we would find is that the middle value would be in the 6s. So let me show you how we would figure that out here. What we need is this cumulative frequency column here, and it's based then on taking the frequencies and just adding them together as we go. So that's the less than cumulative frequencies. So 2 plus 2 then is 4, plus 6 is 10, 22, 37, 56, and so on like that, all the way down to 82 in this example. Now the median is equal to the 50th percentile. And so it's the value of rank n over 2, or another way of saying that would be 0.5 times n, which in our case would be equal to 0.5 times 50, because that's just our n in this particular case, is equal to the 25th value. Now remember, the median in itself is not the number 25, it's the number that holds that position. So if we were to do this with ungrouped data, it'd be n plus 1 divided by 2. It was the 25.5 value. Here we're just simply saying 0.5 times n is equal to the 25th value, because the data are grouped and we've lost some precision here. Now in this particular case, it's really easy to find that, because what we do is we go down the cumulative frequencies here, and what we find here then is the numbers keep adding up here until we get down to this particular point here. So we got 37 to the end of the 5s. By the time we get to the end of the 6s, we're up to 56 values. And so that means that let me back up here. Our n in this particular case then is 82. So this is the 41st value. There we go. My mistake. Okay. So by the time we get to the end of the 5s, we're at 37 values. By the time we get to the end of the 6s, we're up to 56 values. So the 41st value, half of that 82, is in that particular class. And so that just simply means that the median is equal to 6, because they're all 6s in that particular class. Now that's a very simple example. We're going to expand that now to a more complex kind of problem, and that's where you don't just simply have one value in each class, one possible value in each class, so a bunch of 1s, a bunch of 2s, a bunch of 3s, but instead you have a range of values, which is what we have with the ages of the 50 people. So you've seen these data before here, the age classes, and we use this to calculate. Back in Unit G, we looked at this as a table of frequencies, and then we calculated the grouped mean, and later we'll take a look at the group standard deviation. But the original data is back here. So here's the 50 people here, and so we took a look then at calculating the median of these 50 people when they were ungrouped, where you saw every number and they were not put into a table, not put into classes. The next example is we'll also take a look then at this guy right here, the median ages of the marks of 50 people. So let's continue on down here then, and we've got then the ages of the 50 people, and so we've got the classes here, right? And we've got the class marks. We don't actually need the class marks to do this calculation here. We just need the frequencies, and then we'll need the cumulative frequencies. So let's see how this works. We're actually going to use 3 steps in this process. Step number 1 is we're going to say that the median is equal to the 50th percentile. which is going to be the value of rank 0.5 times 50, which is our n, right? Because the sum of the frequencies is 50. And so that's equal to the 25th value. Again, if we were to do this as ungrouped data, it would be n plus 1 divided by 2, the 25.5th value. But here, we're looking at it as group data, so we've lost some precision, so it's just going to be 0.5 times n, 25th value. So that's step number 1. Step number 2 is we've got to figure out what class that's in. So that's in class, and this is where we're going to jump over here to the cumulative frequency column, and we're just simply going to add the frequencies as we go. So 0 plus 1 is 2, 3, 5, 12, 22, 34, 46, and 50. Just adding the frequencies as we go down. Now we're looking for the 25th value. Let me just change colors here. So the 25th value is going to be in this class here, which is going to be the 70s. And the reason for that is that we have 22 values that bring us to the end of the 60s. We have 34 values by the time we get to the end of the 70s. So the 25th value is somewhere in that class, the class of 70 to 79. Now what we do is we go to this really ugly looking formula here. And so we're going to take a look at this formula up here, the pth percentile. And the pth percentile can be used to calculate any percentile. The median is just the 50th percentile. So we'll start there, but then in another problem we'll take a look at calculating the 30th percentile and so on. So the formula that we use here is the median, which is the 50th percentile, is equal to L plus P over 100 times N. And this can be a big N or a little n, it doesn't matter, minus M over F times C. Now, let's take a look at each of those. So, up here, the definition of L here is it's the lower bound of the class that contains the pth percentile. So in our case, the 50th percentile is in the class of 70 to 79. So it's the lower bound of that, which is 70. All right, the next part here is just the P over 100 times N, and again, that can be a little n or a big N. And we've actually already calculated that. So this calculation here was done right here. And so that is where we get our 25 from. Okay. The M is a little goofy here. Let's go and find the M here. The definition of the M here is it's the cumulative frequency up to the lower bound of the class that contains the pth percentile. So up to the lower bound, so up to 70, we've got 22 values. 22 values to the end of the 60s before we get into the class that contains the median. So we subtract off those 22 values. The F is just the frequency of the class that contains the pth percentile. And then, while I'm here, the C is the width of the class. So let's take a look then at those down here. Here's the frequency of the class that contains the median, and the width is 10. Now, you might think that it's 9, because 79 minus 70 is 9. But if you count on your fingers the number of integers, 70, 71, 2, 3, 4, 5, 6, 7, 8, 9, I actually counted 10 numbers there. And that's because you consider these data to be continuous in nature when we're dealing with this formula. In other words, the 70 to 79 class actually goes right up to the end of the 79s. It butts right up to the 80s. I guess when we're talking ages, we tend to round, of course, to the nearest year, but you could round to number of days or hours or even minutes. Of course, that's how they measure when a child is born, what minute that they're born at. I suppose you could go down to seconds and so on, but they're not that precise. So it's continuous in nature. So really the way you want to calculate this is this way. You take the lower bound and subtract it from the lower bound in the class above. So 80 minus 70 is equal to 10. So what we've got here then is we know it's going to be some number greater than 70. We want to go to the 25th value, but there's 22 values before we get to the 70, so we're going to subtract them off. That means we're going to go 3 values into the class. 3 values into a class that has a frequency of 12 is 3/12 of the distance of the class width. So 3/12 then, of course, is a quarter, and so we're going to go 70 plus 2.5 gives you 72.5, and that is how you calculate the median. All right, I'm going to continue on here with the marks for 50 students here then, and show you how this guy works here. So the first thing that we're going to do is find the median. So step number 1, the median is equal to the 50th percentile, which is going to be the value of rank 50 times n. This one also has an n of 50. They're not all going to. And so that's going to be the 25th value. All right, let's go and add up all of the frequencies here in the cumulative frequency column. 1 plus 9 is 10, plus 15 is 25, 38, 46, 49, and 50. So that's going to be in class 50 to 59. And that's because we're taking a look here then at the cumulative frequencies, and we can see by the time we get to the end of the 50s, we're actually right at that 25th value, right there. So it should be at the end of the class 50 to 59. So now what we do is we use this formula. And we say the 50th percentile is going to be equal to L plus P over 100 times N minus M over F times C. So the lower bound of that class is 50 plus, and then we're going to the 25th value. So we've already calculated this guy here. So just like the last problem, but that's because we had the same n. The m is going to be this guy right here, the number of values that came before the median class. And then we've got the frequency of the median class, and the width is going to be the difference between 60 and 50, which is 10. That actually comes out to be 60. And you might say, well, what the Frodo? That doesn't make sense, because that's actually the beginning of the next class. But remember that these are considered to be continuous data. And so it butts right up to the end of the 50s, which is the beginning of the next class, the 60s. So it's right on that line there. So the median actually is 60 then when you follow this formula. All right. Now, before you try the next one here, stop the video and try it yourself. So we're talking about the 30th percentile here. And then see what you get. See if you get the same answer as me. Okay, I'm going to assume that you've done that. Recall that the median is simply the 50th percentile and that the formula can be used to calculate any percentile. Find the mark the student would have to make so that only 30% of the students have marks less than that. So step number 1 is we're looking for the 30th percentile. And that's going to be the value of rank 0.3 times 50 is equal to the 15th value. That's going to be in class. It's actually the same class as the median, 50 to 59. All right, take a look up here, and you'll see that by the end of the 40s, we're only at 10. By the end of the 50s, we're at 25. So the 15th value is somewhere in that class, 50 to 59. So now let's apply the formula. So the 30th percentile is going to be equal to, and just take a look at this formula up here. So the lower bound is going to be 50 plus, we're going to the 15th value. The m is going to be 10, just like above. This guy right here. The frequency is 15, and the width is 10. So it's actually really similar to the one above. The only difference actually is in, instead of going to the 25th value up here, which is what the median was, we're going to the 15th value, which is the 30th percentile. And so that's going to come to 53.33. So that's the 30th percentile. All right, I'm just going to set you up on this next one here and say, find the mark so that the student has to achieve so that only 10% of the students have marks greater than that. So find this mark so that 10% or above. What percentile is that? Well, that's the 90th percentile. So what you're going to do here is you're going to, instead of taking the 10th percentile, you look for the 90th percentile, which would be 0.9 times 50 is equal to the 45th value. And if you take a look at that up here, I want you to finish the rest. We'll take this up in class, but it'll actually be in this class here. Not in the 50s, but in the 70s. Just take a look at the cumulative frequencies. So I'm going to let you finish that. The answer turns out to be 78.75, and you can try that, and then we will move on to the mode next. So that ends the lesson here.